Hello and welcome back to all. Today we shall start our chapter number 1, that is Cartesian coordinate system. So first of all we should know what is a coordinate system and why it is required. Say for example, if we want to specify the position of a particle or position of any object, then what happens? We need some reference point to specify the position. Suppose a particle is having constraints, that means what, it is having 3 constraints, that means it cannot move in any direction, then it will remain at a point only and it cannot move anywhere. If we remove one of the constraints, suppose this is the particle which is having a constraint so that it cannot move anywhere, but suppose we remove one of its constraints, then what happens? It can move along, say, one of the direction. I will call this as a y direction. So it can move along the y direction. Now if I remove another constraint of this, so in this case what happens? There is only 2 constraints on this particle now, so it can move along y direction. Therefore, by specifying the y position, we can know where the particle is after certain time, if it's moving with a constant velocity or so. And if we remove one more constraint so that there will be only one constraint along x direction, then what happens? This particle can also move along this z direction as well. Then what happens? That particle is free to move in this plane itself, plane of the board. And if we remove this constraint also, that means what, the particle is not having any constraint, so particle is a free particle, then we will have along x direction also, so that the particle can move anywhere in the space along x, y, z directions. Of course there will be negative x, negative y and negative z here below also. So this will be like this, this will be negative z, this will be negative x, and this will be nothing but negative of y direction, and this is the origin. So by specifying this thing, we can specify the position of a particle. Okay. Now there are various systems required to specify the position of a particle. So the simplest one is nothing but Cartesian coordinate system. This is the simplest coordinate system, that is called as the Cartesian coordinate system. The other major coordinate systems used are nothing but spherical polar coordinate system and cylindrical coordinate system. And as well as we shall consider general curvilinear orthogonal coordinate system, so that we shall consider later on. So at present we shall consider the Cartesian coordinate system. So what is a Cartesian coordinate system? In case of a Cartesian coordinate system, there are 3 mutually perpendicular planes. Rather 3 mutually perpendicular axes. So I can draw these axes over here. So I will draw this as z axis along this height. Then this is our y axis and this is our x axis. So these are the 3 axes, that is x, y and z axis. They are mutually perpendicular to each other. Okay. Now for Cartesian coordinate system, it is the simplest coordinate system. So the unit vectors are nothing but, as you know, they are nothing but I cap, j cap and k cap. So these unit vectors I cap, j cap and k cap, they are called as unit vector because their magnitude is 1. And moreover, in case of Cartesian coordinate system, their direction is also constant throughout. Okay. And they are mutually perpendicular to each other. So that property we shall use later on. Now if I want to specify a particle, say I will consider some particle somewhere here. Okay, of course I will draw it on the board because we don't have a 3-dimensional space available here. So but this particle will be like this somewhere. It will be somewhere like this. This particle will be here, like this. Okay. So if I consider a point here, say point capital P, suppose it is here, then I will consider the coordinates of this point capital P as P, X, Y and Z. Okay. And this is our origin, of course, that is nothing but what? 0, 0, 0. So I will draw a position vector from O to P. So it will be like this. This is the position vector from point O to point P. And this vector, we will call it as what? Small r bar. I will call it as what? Small r bar vector. Now, this vector is nothing but what? Since we know that along x, y and z directions we have unit vectors I cap, j cap and k cap. Therefore, this vector, that is r bar, we can write down it here. I will write down it here. R bar can be written as x into I cap plus y into j cap plus z into k cap. Okay. Now to specify the x, y and z coordinate, what we have to do is we have to draw perpendiculars here. So what I will do is from this point P, I will immediately draw a perpendicular on z axis from this point. So rather it will be like this. It's a perpendicular actually. Okay. So this distance from O to this point, okay, from O to this point, this distance will be nothing but our z coordinate. So this much distance is our z coordinate. Now what I will do is I will draw a perpendicular on this plane. Remember this x axis is like this. It is drawn like this, but actually in 3 dimensions it is like this. So I will draw a perpendicular on this plane. That plane will be like this, xy plane. So I will draw a perpendicular on this xy plane from this. And again from this perpendicular, I will draw the perpendicular on y axis as well as I will draw a perpendicular on x axis. Then this distance will give us x coordinate, because this is the x distance, and this distance will give us what? Y coordinate. So this is our y coordinate and this is our x coordinate. So by knowing at which point this cuts x and y axis, okay, rather how much x, y and z are required, we can determine any point in the space P, x, y and z. Also we can go to the negative axis anywhere. Okay, so basically there will be actually 8 quadrants here, because these are the 3 axes. If we consider the 2 axes, they will have 4 quadrants, and if we have 3 axes, there will be 8 quadrants. I think later on I will show it with the help of some software on the computer also. So for time being you have to understand this, because there are 3 perpendicular axes and they will make nothing but what? 8 quadrants. 4 quadrants will be above here and 4 quadrants will be below here. Okay. So this is what we have to consider in the Cartesian coordinate system basics. Now to know this distance is nothing but what? We can use distance formula to find out this, or also we can find out mod of this vector. Okay, so mod square of this vector is nothing but what? R bar dot R bar, that will be x square plus y square plus z square. So if I consider this R bar dot R bar, it will be nothing but what? X I cap plus y j cap plus z into k cap dot x I cap plus y j cap plus z k cap. So if you consider this dot product is nothing but what? Mod of R bar x square. So this is nothing but x square plus y square plus z square. So this gives nothing but this distance r, which is also called as mod of R bar, or also called as mod of OP if we use the distance formula, OP bar vector, or also called as OP also. So this will be nothing but of course, positive square root of what? X square plus y square plus z square. Now here we have to consider a positive square root because distance is always positive. Okay. Now any point can be considered as a point of intersection of three different planes. So that is what I have drawn it here. To save the time, I have already drawn this here. So we shall consider the three different planes. So I will just remove this part. Okay. So okay, no need. I can explain it here. So we will consider the three different planes here. So first, this is x, y, z axis. Then the first plane is nothing but what? It is like this. See here, this I will show the plane here. Okay, this x-axis is like this, and this plane is cutting it at somewhat this point. Okay, so this plane is nothing but plane A, B, C, D, and this is like this. This is not on the board; it is above the plane of the board. So this plane cuts this x-axis at a location at a point called as what? X prime. So we call this plane as x is equal to x prime plane. So we have this A, B, C, D plane, which is x is equal to x prime plane. Then we have another plane here, that is nothing but what? This plane, that is P, Q, R, S. Again this plane is like this. Okay, so this plane cuts the this plane actually, okay, I have to write it in a proper way actually, 1 minute. This plane is nothing but what? It is cutting z axis. So we have this plane as what? Z is equal to z prime plane. Because it cuts z axis at somewhere here, this point. So this is z prime point. So therefore this is a z plane. Z is equal to z prime plane, and this another plane is nothing but what? H, I, J, K. So this plane cuts H, I, J, K. This plane is like this. So it cuts our y axis somewhere here. That is nothing but we can call it as y prime, and therefore this plane is nothing but what? Y is equal to y prime plane. So these are the three different planes. Now if we draw the lines from centers of these planes together, so what will happen? Say I will draw a line A, B, C, D. So I will draw E, F from this point to this point. Then I will draw for the another, say which is a parallel to the y axis is nothing but what? H, I, J, K. We will draw this LM, line LM, and for the plane which is a parallel to our which is perpendicular to our z axis. So that is nothing but what? P, Q, R, S. So we will draw P, U line here. So the common point of intersection of these three lines is nothing but what? Point capital P. Therefore the coordinates of point P are nothing but x prime, y prime and z prime. These are the three coordinates. So therefore to have a point in a three-dimensional space, we should have what? Three surfaces cutting each other at a particular point. We will see this with the help of softwares in our later discussion, so that we can visualize it in a much better way. But here again you have to visualize it in to understand what we are going to say here. So therefore a point is nothing but a common point of intersection of these three different planes, that is x is equal to x prime, y is equal to y prime and z is equal to z prime. So this is what we have to consider in case of a Cartesian coordinate system. Now we shall continue with another coordinate system, that is called as the spherical polar coordinate system, in our next lecture. Thank you for patient listening.